This video will discuss about the topic composition of function. Okay, so we have to consider two sets. Let f is a function defining from set A to set B, and g is a function defining from B to C. So GOF function will define from A to C. Okay, so here I have taken three sets: set A, set B, set C. Okay, so by F rule, A linking with B, and by G rule, B linking with C. So I have taken one element which is belonging to set A, x belonging to set A. When we apply F rule on the element of set A, so we'll get the range of f, like f of x is equal to y, just we are writing here. So f of x is the range, is the domain of G, and range of f. Now if you apply G rule on element of set B, so we'll get the range of G. So G will apply on set B. So g of y we can write, okay, and g of y another way we can write g f of x. Okay, so g of x, and directly if you want to link A with the C, so by GOF function we have to link. So by GOF, if you write here GOF of x is equal to g f of x. Okay, we will solve some question on the basis of GOF function. Okay, but here just if you want to expand GOF function, so g f of x we have to write. Okay, now for existence of GOF, when you will find the GOF function, if range of f is a subset of domain of G. First condition, if range of f is a subset of domain of G, then you have to find the GOF. Okay, and if range of f is not a subset of domain of G, then GOF will not exist. GOF doesn't exist. Okay, GOF will not exist. Exist. Okay, if range of f is not a subset of domain of G, and for if range of G is a subset of domain of f, then for function will exist here. Okay. So on the basis of composition of function, how will find the inverse of function? This is also important topic. So let's see, if function is defining from A to B, if there exists for invertible function, if there exists a function g which is defining from V to A, such that if GOF function is equal to the identity function and fog is also identity function. Okay, means if function f is defining from A to B, then there exists a g function which is defining from B to A. And how will they will exist? If GOF is equal to identity function, fog equal to identity function, then we have to say f is called the invertible function. Okay, if these two condition is we are getting in any question, like f is defining from A to B and g is defining from B to A, and GOF is equal to identity function and fog equal to identity function, then we can say that f is invertible. Okay, f is called invertible function. Now if f is called invertible function, so g what? G is here inverse function of f. Okay, so g we can write f inverse, z is equal to f inverse we can write. So GOF equal to identity function, so identity function on set A, so z is inverse, so we can write here f inverse of f is equal to x. Okay, and fog is equal to ib is this element, generally we are taking set B as a y, so f of f inverse is equal to y. Okay, so by composition of function also we can find the inverse of the function. Okay, now see one question on the basis of composition of function. If the mapping f and g are given by f is equal to 1 2 3 5 4 1 and g is equal to 2 3 5 1 1 3, then we have to find fog and GOF. So for finding fog and GOF, you see the solution, we have to find the range and domain of both function. So range of f, what is here? Range of f, second elements we have to consider the range to 2 5 1, 2 5 1, this is range, and domain of f, what is? First element 1 3 4, 1 3 4, and same way domain of g, what is here? Domain of g 2 5 1, and range of g, what is? Range of g is 3 1 and 3, that means 3 1 1. Just wait, because 3 is repeating 2 times, so we have to write 1 times. Okay, so range of G is 3 1. Okay, for Goff we have to check range of F is the subset of domain of G. So range of F, what is here? 2 5 1, and domain of G, what is 2 5 1. So we are getting a range of F is a subset of domain of G. Okay, so Goff exists. Okay, if Goff will exist here, so how will find the Goff function? See, Goff. So what is the domain of F? If we want to find Goff function, so we have to apply Goff rule on the domain of F. So domain of F, what is here? 1 3 4. So firstly we have to apply Goff on 1. Okay, so how we'll expand here? G F of 1. Okay, G F of 1. And what is the value of F of 1? Like F of 1 equal to 2, because 1 linked with 2, so F of 1 is equal to 2. Also we can write like that, like F of 1 2, F of 3 5, F of 4 equal to 1, G of 2 equal to 3, G of 5 equal to 1, G of 1 equal to 3. Okay, so F of 1, what is here? 2. So you have to write here G of, on the place of F of 1 we have to write 2. And what is the value of G of 2? 3. So G of 2 equal to, G of 2 is equal to 3. Okay, now same way Goff we have to apply on the 3, because the domain of F is 1 3 4. So already we have applied on 1. Now Goff of 3. So G F of 3. Okay, F of 3, what is? F of 3 is 5. Okay, so G of 5, and what is the value of G of 5? Is 1. G of 5 equal to 1. And Goff of next one 4. So F of 4, what is here? F of 4 is 1. So G of, firstly we write F of 4. Okay, then G of 1, and G of 1, what is 3. Okay, this is Goff function. So how will write in roster form? Goff, like 1 linked with the 3, so 1 comma 3, 3 linked with 1, so 3 comma 1, and 4 linked with 3, so 4 comma 3. This is Goff function. And same way if you want to find for, so for we have to check range of G, the subset of domain of F. So what is the range of G? 3 1, and domain of F 1 3. So we are getting here the range of G, the subset of domain of F. So if range of G, the subset of domain of F, that means fog exist here. And fog exists, then how will find fog? Again just see fog. So what is the domain of G here? Domain of G is 2 5 1. So fog we have to apply on the elements 2 5 1. So fog of 2. Fog of 2, what will be here? F G of 2. Okay, and G of 2, what is? You see, G of 2 equal to 3. So G of 2, on the place we have to write F of 3, because G of 2 equal to 3. Okay, so G of 2 equal to 3. So F of 3 we have got, and F of 3, what is? Once again see F of 3 5. So on the place of F of 3 we have to write 5. And fog of next one 5 we have to apply, fog of 5. So we have to write here F G of 5. And what is the value of G of 5? Once again you see G of 5 is 1. So we have to write here F of 1. Okay, and F of 1, what is here? F of 1 is what is 2. F of 1 equal to 2. And last fog on 1 we have to apply. So F G of 1, and G of 1 is equal to 3. So F of 3, and F of 3 is equal to 5. So fog we have to write here like that. So fog in roster form 2 5 5 2 and 1 5. This is for. Okay students, we'll solve some more question on the basis of composition of function.